Hey guys, this is Advanced Math and we are ready to begin Unit 2. And we're going to start off today by graphing systems of equations. Graphing systems of equations. This should be familiar to you. It may have been a few years since you've done it, but hopefully it will come back to you quickly. Let's take a look at this opener. I want you to graph the expression on a number line. And our expression is x is greater than negative 2. Now you may have only been recently in the past few years graphing in our Cartesian plane with the 4 quadrants, and you may have forgotten how to graph on a number line. So first we're going to find our point, which is negative 2. We know that it's greater than, not equal to, so we're going to make an open circle on the negative 2. And because it is greater than, it is going to go to the right. Remember, greater has that R right there. Greater than goes to the right. And so our graph will look like this when finished. Open circle on the negative 2 and the line going to the right. What about the absolute value of x equals 4? Well, hopefully you remember that absolute value always gives us 2 answers because there are 2 numbers that are 4 spots away from 0 or 4 spots away from the origin. We have negative 4 and 4. Now there's no line on this one because there are only 2 possible answers. In our previous question, we had lots of possible answers, lots of numbers greater than negative 2. But here, there are only 2 possible answers, 2 things that equal the absolute value of 4. So just 2 dots, closed circles on negative 4 and 4. Now we can graph on a number line, but we can also graph on this thing, which is called the Cartesian plane, named after Descartes, a famous French mathematician. The Cartesian plane allows us to enter x and y coordinates. X tells us whether we're moving left or right. If it's a positive x, we move to the right, and a negative x, we move to the left. This should look very similar to the number line. Y, the y-axis, is also like the number line, but instead of left and right, we're moving up and down. Positive tells us to move up, and negative tells us to move down. This should be pretty logical to you. If we're standing right here at point 0, 0, or the origin, and we get in a hot air balloon and we go up, our elevation is going to increase by a positive number. As we go up 1 foot, 2 foot, 3 feet, 4 feet, 5 feet, our elevation goes up. That's a positive number. If we were to dig down into the ground, perhaps we're digging a well, or when you're little, maybe you had that idea that you could dig to China. As you go down into the ground, your elevation decreases or becomes negative. You're going down under 1 foot, 2 feet, 3 feet as you drill down. So that should make some logical sense to you about going up being positive and down being negative. And we can use the Cartesian plane then to graph lines or graph points on this Cartesian plane. Hopefully you remember slope-intercept form. Y equals mx plus b, where m is the slope of your line, in this case 2, and b is the y-intercept, or at what point it crosses the y-axis. That's your vertical axis there. Let's see if we can graph this line. Okay, here we have the y-intercept at 1. It's crossing the y-axis at positive 1, and our slope is positive 2. Remember, 2 is just a rational number, 2 over 1. So our slope is up 2 and to the right 1. Up 2 to the right 1. And we repeat that process. Up 2 and to the right 1. We could also do to the left 1 and down 2. And we'll see that it hit those same points on that same slope. So hopefully you remember that y equals mx plus b. What about y equals negative 1/2 x minus 2? Well, this is our y-intercept. So negative 1, 2, we're going to go down below ground here. And our slope is negative 1 over 2. So negative 1, which is down 1, and 2, which is to the right 2. Our line should look like this. Down 1 and to the right 2. Down 1 and to the right 2. Connect that line and we've got our line there. Our lesson objective for today is this. You, the student, will solve systems of equations by graphing. Now that may sound complicated, but it's actually pretty easy. Hopefully, again, this comes back to you as we go through this. So when you're solving systems of equations, you're being given 2 different equations, and basically we want to know what answers will satisfy or make both equations true. what points or what numbers will work with both equations. That's what we're trying to do. And we can do that by graphing. So first we're going to graph the following equations on the same coordinate plane. The first thing that we need to do before we can graph them, though, is put them in slope-intercept form, that y equals mx plus b. And we do that by using a little bit of algebra. So here we want the y by itself, which means we need to eliminate this x. Subtract x. And over here we want the y by itself, so we're going to have to do a few more steps. And here, once we subtract the x, we get y equals negative x, or if you want to write that 1 in there so you don't forget about it, negative 1x plus 5. Over here, subtracting the x gives us negative 3y equals negative x minus 3. We still don't have that y by itself, so we need to divide by negative 3, excuse me, to get the y by itself. And when we do that, we get y equals positive 1/3 x plus 1. And the reason we get positive 1/3 and positive 1 is because when you divide negative 1x by negative 3, you get positive 1/3. And negative 3 divided by negative 3 is positive 1. So we now have both of our equations in y equals mx plus b. Once we've done that, we can graph those on this coordinate plane or Cartesian plane. You'll hear it both ways. So let's take a look at this first one. This is our y-intercept. So it crosses the y-axis at positive 1, 2, 3, 4, 5 right here. And our slope is negative 1. So down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. And we'll draw a line here in just a minute to show that line. Our second equation has a y-intercept at positive 1. So we're going to make a mark right there where it crosses the y-intercept. And its slope is 1 over 3, or positive 1 over positive 3. So we'll go up 1 and to the right 3, and up 1 and to the right 3. And even without drawing my line, hopefully you can see that point where they both are going to cross. Let's go ahead and graph those lines. And in doing so, you can see where those points cross. They cross at 1, 2, 3, the x-coordinate of 3 and the y-coordinate of 2. Those two lines intersect at 3, 2. What that tells me is that putting a 3 in for x and a 2 in for y, substituting a 3 in for x and a 2 in for y, will work with both of these equations. We'll make both of them true. So we've identified the point of intersection on the graph at 3, 2. A system of linear equations is made up of two or more linear equations. We talked about that before we graphed. A system of linear equations is just two equations that, when graphed, will form a straight line. That's what linear means. Any ordered pair that makes all of the equations true is a solution to the system of equations. 3, 2 was a solution because it worked with both equations. Let's take a look at another example. X minus y equals 9 and 2x plus y equals 9. The first thing we need to do is put them in y equals mx plus b if we're graphing, but let's just do a quick test. Let's say we're given the point 11, 2, and let's find out if that's a solution to the system. What we'll do is substitute our x and our y, our 11 and our 2 into both equations and see if we get true statements. When we substitute 11 and 2 into the first equation, we get 11 minus 2 equals 9, or 9 equals 9. That is true. When we substitute it into our second equation, we end up with 2 times 11 plus 2 equals 9, or 24 equals 9. That is not a true statement. That is false. Therefore, 11, 2 is not a solution to the system. It did not work with both linear equations. So let's find out what a solution to the system might be. Let's try 6, negative 3. We're going to plug those in and evaluate. So go ahead and plug and chug. Try this on your own. Pause the video, come back and see if you're able to find the answer. When we plug both of those in, we end up with 9 equals 9. That's a true statement. And over here, 2 times 6, which is 12, minus 3 is 9. So 9 on this side equals 9 on this side. Both of those are true. So 6, negative 3 is a solution. Okay, in fact, it's the only solution. Now, we could just plug and chug lots of numbers until we eventually find the one that works for both. but graphing allows us to find the solution without having to plug and chug a bunch of different possible answers. So the way that we solve a system by graphing is first to graph both equations on the same coordinate plane after we've put it into y equals mx plus b form. Then we'll identify the solution, which is the coordinates of the point of intersection. Like in the first graph that we did, the intersection was at 3, 2. That's our solution. We'll then check the solution by substituting it into each equation. We'll go back and plug and chug and make sure we did all of the steps correctly. So let's solve this system by graphing. If you're watching this video at home, try to do this on your own, maybe on some graph paper or over in the margin, and see if you can find the solution to this system of equations. In y equals negative x minus 2, our slope is negative 1, and our y-intercept is 0 at negative 2. In y equals x plus 4, our slope is 1, and our y-intercept is negative 4. When we graph both of those equations, there's the first one, the y-intercept of negative 2, and here's our second one at negative 4. You can see their point of intersection. Using what we know about the Cartesian plane, we can determine that this is 1 and negative 3. So our coordinates are 1, negative 3. If we were to plug this back into the equation, we would find that indeed both the x and the y do work. 1 and negative 3 both work in both equations, so it is a solution. Hey, you try this one. X minus y equals negative 5, and 3x plus y equals 7. Pause the video, put both equations into slope-intercept form, which is y equals mx plus b, graph, and see if you can find the solution before restarting this video. Once you graph both lines, you should have had two systems, or a system that looks like this. And you can see that the point of intersection is at, moving left on the x-axis, negative 3, and moving up 2. Negative 3, 2. Sometimes a system of equations contains equations that name parallel lines. Since parallel lines have no points in common, such a system of equations has no solution. Remember, parallel lines run side by side, essentially for all eternity, and never cross. If they never cross, then they don't have a solution. Sometimes a system of equations contains graphs that are on the same line. Maybe you have one line, and then you draw another line right over the top of that. That was not a very good line. When you have a system of equations that fall on the same line, then these are said to coincide. And the solution is the set of all the points on the line. And what we'll often do is for the solution, write the equation of the line, the y equals mx plus b slope-intercept form of that line. Let's take a look at two examples. X plus y equals 3 and 2y equals negative 2x plus 6. We find that the slope for both of these is negative 1, and the y-intercept for both of these is positive 3. These are the same slope, the same y-intercept, and therefore the same line. So we say that these coincide, and our solution is the equation for the line. That will cover all the points on the line. Let's take a look at this one. X plus y equals 3 and x plus y equals 7. Here we have the same slope, but not the same line because they have different intercepts. But because they have the same slope and different y-intercepts, they are parallel. Parallel lines never cross, so our solution is nothing, null, not able to have a solution. They don't cross. Here are the possible solutions to a system. First, your lines could be intersecting. If that happens, then your graph of your two lines will cross. The number of your solutions, you'll have 1, and your answer will be whatever the ordered pair is that names their intersection. Parallel lines run side by side. There are no solutions, so your answer will be the 0 with a slash to it. No answer, no solution. And coinciding lines look like this, one on top of the other. The number of solutions is infinite because the two lines will run one on top of the other forever. And then the answer is all the points on the line, which means we will write the equation of that line. Today we solve systems of equations by graphing. If you have any questions, be sure to ask me next class. class.